welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. So everybody, today we are going to see lecture number 3 of alcohol, phenol and ethers. I know there was a big gap between that, but I thought of completing that. Why? Because you know, one little bit part we were left with. I want to complete it so that we can start with the other chapters after this. Right? But before that, let me tell you that our Sigma crash course is live, and here we are going to teach you high weightage topics that we have specially analyzed from past 10 years, right? And they are short topic that will definitely be there in your exam. And guys, we are not just going to tell you, okay, this is the topic, this is the theory part, that's it. No, we are going to give you practice questions, we are going to give you homework as well based on that, so that you can practice yourself, and next day we'll ask you if there is any problem. Then the problems that can also be answered in Telegram group and certain specific group that we will make for our crash course students, right? Okay, yes everybody, so link is in the description, go and check that out, right? You are totally going to love it. The content, right? It's not just, okay, this is the course, same content will be there. No, actually in a summarized form, not missing even a single point. This particular crash course has been specially designed, guys, and I can like guarantee you, if you take this crash course, you're not going to regret it. It's a very good revision. Even those students, right, who are right now thinking, ma'am, I have just prepared for CBSE, I am like zero, ma'am, in this, they will also be able to understand, because guys, we are not doing that teach you full chapter, even unnecessary topics in just 1 hour. That we are not going to do. We are going to teach you high weightage topics, but in detail with the question practice, that you have full confidence. Because see, every correct answer is going to give you 4 marks, and we have to focus less on negative marking, more on positive marking. That can only happen if you have a concentration that these are the topics, important topics that I have to have mastery on, and after this course you will have mastery on those topics, right? So chemistry, physics, mathematics, Shreyas sir has already shown you. You can go and check out the video as well. The topics that we are going to teach you, you can analyze yourself. Are these the important topics? Yes, you can analyze past 10 years question paper. You will see those topics are again and again repeated, right? And if you are like a school going student, even then, this is 6:30 to 10:30 or 6 to 10. That will be the timing of the sessions. That is why it will be like easy for you, right? Okay. Yes everybody, yes. For more detail, you can click on the, just go to the live section, Sigma crash course. Shreyas sir has taken a dedicated session explaining all the features of this particular course. You can go and check that out. The price, everything is mentioned there, right? Now let us start with the remaining part of alcohol, phenol and ether, that is ether. So let's talk about that. So here, wait a minute, let me just put on my specs, because otherwise I'll feel like a blind person, right? Yes, I do feel like that. Do you also feel like that? No, ma'am. Ma'am, we are not boodha like you, ma'am. Okay, so now let us see classification of ethers. First is simple or symmetrical ethers, then there are mixed or unsymmetrical ethers. In simple ethers, you have both the alkyl chains same. In unsymmetrical ethers, the alkyl chains are different here, right? Okay. Now, if you talk about the angle here, CO, bond length is 141 picometer, and this bond angle of COC is 111 decimal 7 degree. You can say approximate 112 degrees it is, right? So why it is so? Ma'am, it is a tetrahedral geometry. If you see, it's a tetrahedral geometry. Ma'am, in tetrahedral geometry, the angle should be 109 degree, ma'am. But why the angle has increased? This is a very important question. Because of the alkyl groups that you have here. Because of the alkyl groups that you have here, this alkyl group and this alkyl group will cause repulsion here, and that is why the angle will increase here, and it will increase to 111.7. Right? Bond angle is slightly greater than this due to repulsive interaction between the bulky alkyl groups. Right? Now let's talk about the different kind of ethers that exist here. If you see this is actually alkane, same number of alkane, same number carbon alkane. If you see C2H5O, C2H5, this is ether. If you see, this is alcohol. If we talk about the boiling point here of alkane, if you compare alkane, ether and alcohol, alcohol has maximum due to hydrogen bonding, then you have ether which has dipole-dipole interaction, but still there is polarity, that is why the dipole-dipole interactions are going to be stronger as compared to alkane, right? That is the reason here you will have more boiling point as compared to corresponding alkane, right? Then guys, let's talk about isomerism. What is isomerism? Everybody in the chat box? Yes, everybody in the chat box. What is isomerism? See, isomerism is same molecular formula, different arrangement of atoms. Ethers show firstly functional isomerism. Ethers are converted, ethers and alcohols can have the same formula. Like this is alcohol, and with the same formula you can have ether here. With the same formula you can have ether and alcohol. So ether and alcohol exist in the functional isomers. Then guys, we have metamerism, in which bridging ligands like ether we have, and ether shows this how the two alkyl chains are going to be different. Here you have ethyl and ethyl. Here it is methyl and propyl. So here different and here different. Another metamer can be methyl and this is isopropyl. So these are also different. So these are the metamers of each others, like 1 and 3, 2 and 3, and then you have 1 and 3, 2 and 3, yes, then 1 and 2, all these are metamers of each other, right? Okay. Chain isomers. Chain isomer, most of the functional group they will show. Chain isomer means the parent chain is going to be different here. Here you will see the parent chain is going to be 1, 2, 3, 4 carbons. A parent chain means longest carbon chain you will select here, and here it is going to be 3 carbons. This is a substituent and this will a substituent. This is an alkoxy substituent. This is a alkoxy substituent. This is also alkoxy substituent. That's why it is written as methoxy. And this is a substituent in the parent chain, that is simple methyl. That's why it is written as 1. This is 1 methoxy and 2 methyl. So number of carbon atoms here are 4 in the parent chain. Here it is 3 in the parent chain. Okay. Now let's understand dehydration of alcohols. So when an excess of alcohol is heated with at 140 degrees Celsius in presence of protic acids like H2SO4, H3PO4, dehydration will take place. See, if it is at 170 degrees Celsius, then alcohol will be converted to alkene, that we have seen previously as well. But if it is at 140 degrees Celsius, then alcohol will be converted to ether, and especially 1 degree alcohol here. So 1 degree alcohol, you will have the elimination of water from here, and that will be converted to ether here. 2 degree and 3 degree are going to give you, because of steric hindrance, they will give you alkene. So you can say dehydration of 1 degree alcohol to form ether is assent to attack. That means it depends upon the steric hindrance. It depends upon the steric hindrance, and that is the reason 1 degree alcohol is going to form ether, but 2 degree and 3 degree, secondary and tertiary, they will give you alkene. Why? Because SN2 mechanism will be very difficult to occur here. Here it is very difficult for these two molecules to take out water because of steric repulsions here, and that is the reason it will cause alkene, it will make alkene by E1 mechanism, and here you will have the formation of major product, that is alkene, and ether is going to be minor product in case of 2 degrees. Similarly, in case of 3 degree, same thing, you will have the formation of alkene as the major product here as well. So dehydration of alcohol, right, to form ether, if you see, to form alkene is 3 degree, 2 degree, 1 degree, and to form ether, it's 1 degree, 2 degree, then 3 degree. So 1 degree will form ether, 2 degree and 3 degree will not form ether. That was your first reaction. Now, second reaction is Williamson synthesis reaction, a very, very, very important reaction, very frequently asked question, right? So heating, here what we do, we have alkyl halide and we have sodium or potassium alkoxide, right? So it's a very good method of preparation of simple or mixed ether. Why? Because here you have alkoxide, this is alkyl halide. NaX will be eliminated and you will have the formation of mixed or symmetrical, or you can say simple ethers, right? Simple ethers, mixed ethers, or you can say symmetrical or unsymmetrical, both are formed here, right? So it leads you to the formation of ROR, and here it follows SN2 mechanism. That is the reason, if you remember this, we have already done before also, but I told you that we will do this in detail here, right? So this follows SN2 mechanism. That means only in one step the reaction is going to occur, right? Only in one step it is going to get attached and then it will break, and this bond will start breaking and this bond will start forming, and then you will have the formation of ROR here. You know what's the catch? What's the most important thing here? This particular line is most important here. Alkyl halides should be primary and alkoxide can be secondary or tertiary, because it's a SN2 mechanism. It will depend upon the steric hindrance, and we are saying that alkyl halide, if you see the mechanism from there, alkyl halide, this should be primary, right? Best cases both are primary. If this is also primary, this is also primary, best case. If you have to make any one of them secondary, you will make this secondary, this primary, this tertiary, this primary. But this secondary not possible, this tertiary not possible, okay? But this one, when both are primary, that is the best case scenario here, right? Okay? This method is not applicable to tertiary alkyl halides. It is not applicable only. It's impossible to do that. Similarly for secondary as well. So if you have tertiary halide, this reaction will give you alkene rather than giving you alkoxide. So with this particular thing, Br will go from here. Br negative will leave, H will leave, and this will be shifted here. That will give you the formation of alkene. Rather than giving you ether, they are giving you alkene. Okay? Due to steric hindrance, secondary alkyl halide prefer undergo. Secondary also has the same thing. Even in secondary, in the same thing, if you have secondary alkyl halide, it will also give you 80% alkene and only 20% ether will be formed. That means alkyl halide should be primary only. If it is secondary, very less product, like 20% will be formed. 3 degree, it's almost impossible. Here 20% approx, very less product will be formed. Okay, understood? For 3 degree, it's impossible. Right, everybody? For 3 degree, guys, it's impossible. For 2 degree, 20% of the ether will be formed only. Very, very small amount. Minor product will be there. Right? Okay. Then the limitation is aromatic halides cannot be used in Williamson synthesis reaction, because in this reaction you have the breakage of this particular bond. Right? And in case of aromatic halides, we know that here this particular bond is a partial double bond, and because of this partial double bond here, it is not able to react properly. This bond will not break, and that is the reason Williamson synthesis reaction you cannot use aromatic halides, right? This is important limitation. Then if you have strong electron withdrawing group on the para and on the ortho position, then this reaction might take place. Then this reaction might take place. If like NO2 group on ortho and para position, then this reaction will take place, right? Okay. This we have studied in Dow's process as well. So if you see this here, now he is saying that you have phenoxide ion, you have CH3Br, right? Br and Na will leave and it will give you the formation of anisole, that is benzene OSOCH3 will be formed here, right? Now the question is, in which of the following reaction the product obtained is tertiary butyl methyl ether, tertiary butyl methyl ether, right? So if you see this reaction here, tertiary butyl ethyl, here this is possible, this is the not possible only. Why? Because alkyl halide cannot be tertiary, right? Ether formation, this is not ether formation, this is the dehydration reaction. Yes, it is ether formation, this is dehydration. Here this will leave and it will give you CH3 OCH2 CH3. This reaction will not take place only. This reaction will also not take place. Can you tell me why? Because this is tertiary. This reaction will take place and it will give you the desired product, that is CH3 OCHC CH3 CH3 CH3, because here alkyl halide is primary in nature, so Williamson synthesis reaction can take place, right? Here this reaction can take place. Answer is C is the correct answer here. Let me know guys if everything is clear till now. Yes students? Is everything clear till now? Okay, okay. Now we have alkoxymercuration, demercuration. In this case, what we will do, you will have RCH double bond CH2. Here, just like oxymercuration, demercuration, you had the formation of alcohol by attachment of OH by Markovnikov rule. So similarly, Markovnikov rule will be applied. You don't need to know the full mechanism here. Just remember Markovnikov rule will be applied. And the alcohol that you are adding here, from here OR dash part will get connected to, this part will get connected to less number of hydrogens. Because negative part is connected to less number of hydrogens. So this OR will be connected here, H will be connected here, and this is the ether that you will have here by the Markovnikov addition. Just like you have oxymercuration, demercuration, on the similar line you have alkoxymercuration. There you add OH, here we are adding OR. That's it. That's the only difference that we have. Okay. So next is heating of alkyl halide with dry silver oxide, right? This is dry silver oxide. When you heat it, you will have the formation of ROR, and here always you will have the formation of symmetrical ethers. Unsymmetrical ethers are not possible in this case, right? Unsymmetrical ethers are not possible in this case, right? Then guys, the next reaction is methyl ethers can be formed by heating diazomethane. Diazomethane means CH2N2. Azo means N2. Methane means CH4. So from CH4, 2 hydrogens are eliminated by azo, that is diazomethane. Right? Now what will happen here? You will have the formation of RO will be as it is. Then you will attach CH3 here, CH2 from here and H from here, right? And N2 will be eliminated here. Basically, this N2 will be eliminated, this CH2 will be in between here. And that will always give you ROCH3 as the correct answer. For example, you have CH3OH here, that will give you CH3OCH3. If you have C2H5OH here, that will give you C2H5OC2H5. So OCH3 will always be there in this case, right? For example, here you have this example I have already told you. For example, here you have a CH, CH3, CH3. So it will remain CH, CH3 twice. This is O. Then you will have, just replace this thing with CH3. That's it. And that is going to be your answer here. Okay, everybody? Clear? Now let's see this question. Who will answer me? Let's see this question. C2H5OH you have, CH2NH2 you have, HBF4, and they are asking you what is the product here. So here answer is going to be C2H5OCH3. That is methyl ethyl ether. So answer is going to be A is the correct answer here. Right, everyone? Okay. Understood? Now let's see the physical properties of ethers. Let's see, everybody. Physical properties of ether. Let's see that, students. Physical properties of ether. Let's see that. Ready, everyone? So, due to large size of alkyl groups, ROR bond angle in ethers is large. We know that the bond angle is large here. Therefore, net dipole moment become less, and therefore ether show. We know that this is O, this is R, this is R. So, these are the lone pair, these are the lone pairs. Here bond angle is large. It will go from here to here. It will go from here to here. Right? Because here the bond angle is large, the resultant will become small, right? So this resultant that you will have here will be small, and here you will have a resultant. If this resultant is small, then this cancellation is less. That means all you just remember that bond angle, if bond angle is high, then this resultant is small. When this resultant is small, then we can say the cancellation is less, and that is the reason large dipole moment is there, right? So net dipole moment becomes less. Wait a minute, no. Resultant is going to be more in that case. Cos theta resultant is going to be more, right? If this resultant is more in that case, this dipole moment is going to be less. So all you have to remember that dipole moment is less in this case, in case of ethers. That is the reason they show low boiling points and low solubility in water. Solubility in water further decreases with increasing molar mass. When you increase the molar mass, see you have O, this is R, this is R. If this part is increasing, hydrophobic part is increasing. We can say solubility is decreasing, right? Okay, because oxygen becomes more hindered and become less available for intermolecular hydrogen bonding with the water. Because what will happen if you have O, this is R, this is R, this will be hydrogen bonded like this. Okay, if this is highly hindered, then this will be less available for hydrogen bonding, so solubility will decrease further. Right, everybody? Now let's do the reactions of ethers. The reactions of one reaction is very famous here, that is the reaction of HX. It's a very important reaction. It's a very important reaction. Okay, let's see that. The cleavage of CO bond in ethers take place under drastic condition with excess of hydrogen halides. We are saying that you have ether, you have HX, right? What will happen? Either of this bond will break. Here with the O negative you will have H positive, and with this you will have X. So you will have the formation of RX and ROH here, right? But the question is, ma'am, which bond will break? Ma'am, will this bond break or this bond break? That is the main question of this particular reaction. Okay, the order of reactivity is HI, HBr, HCl. Again, because down the group size increases, bond length increases, it is easy to break this bond. So that's why it has high reactivity. If you see, in this case, whenever you have an aryl and one alkyl, this bond, because it has partial double bond, this bond can never break. Always this cleavage will take place, and always to O negative you will have H, and to this you will have X. So always you will have the formation of phenol and RX here, right? This is also a very important question, that why this bond can never break, because of partial double bond character, because of resonance here, right? Then if you have mixed ethers, then how the cleavage will take place, right? If you have, let's say, R dash OR, will this bond break or this bond break? So let's talk about two things here, right? When primary or secondary alkyl groups are present, when there is, you can say, no 3-degree alkyl group. Very important this is. This is very, very, very important thing that I am teaching you right now. If both the alkyl groups, none of them is 3-degree, that means it's a SN2 mechanism. Okay, that means it's a SN2 mechanism. So, less sterically hindered will form alkyl halide. Less sterically hindered, less hindrance will form alkyl halide. In this case, less hindrance will form alkyl halide, right? That means, let's say, this is not that. Wait a minute. I think I forgot to write it here. Chalo, no issues. I'll just write this here. If even if one of alkyl group is, alkyl is one of the, if even the one of the alkyl group is 3-degree, then it is SN1 mechanism, right? Then it is SN1 mechanism. In that case, 3-degree will form alkyl halide. 3-degree will form alkyl halide. Okay, what we are saying? If you have no alkyl group, then alkyl halide will be less hindered because it follows SN2 mechanism. If one of the alkyl, even if you have one alkyl group, right, then it will follow SN1 mechanism and 3-degree alkyl halide will be formed in this case. And it will follow SN1 mechanism like this. Firstly, carbocation will be formed. So, stable carbocation is 3-degree, then 2-degree, then 1-degree. That's why 3-degree alkyl halide is formed here. Right, everybody? Let's see this example. Here you have this alkyl and this alkyl. This is 3-degree, this is 1-degree. That means this is going to follow SN1 mechanism. So, 3-degree will be alkyl halide. 3-degree will be alkyl halide. So, this will be CCH3, CH3, CH3, I, that is halide, and other part will be your alcohol. Right, everyone? Okay. And if HI is given in excess, firstly, what you will have, right? If HI is more given, alcohol that you have already formed here, any alcohol that you have, that will further react with HI, and that will form a carbocation here. That means directly what will happen? Here what is happening? This is alcohol that was formed in the first step. You have excess of HI here. This I negative will be eliminated because of these lone pairs. It will attack on this H positive, which is electron deficient. Now we know that this will eventually leave because O positive is very difficult to stabilize, right? So oxygen will be like, give me back my electrons. So this will leave, and how it will leave? When this is leaving from this side, when this is leaving, I negative here will attack here, and you will have the formation of alkyl halide. Okay, the same alcohol that you had, that is converted to alkyl halide. Okay, what I am saying, here you had the formation of alcohol, right? Here you had the formation of alcohol. When you have excess of this one, see, when less of HX is given, you have RX and ROH. Let's say this is R dash, let's say R dash OH is formed. Then R dash OH is converted to R dash X. Okay, so two alkyl halides will be formed in excess of HX, that is RX and R dash X. Even the alcohol formed will be converted to R dash X in case of excess of HX. Okay, everyone? Got it? Yes, students, let's see. Yes. Okay, everybody? Next question is, in a reaction, you have this kind of reaction. HBr, the products are, see, this bond is not possible to break, so here you will have the attachment of H and here you will have the attachment of Br. So it is going to be phenol and CH3 CH2 Br, that is D is the correct answer here. Okay, understood everybody? Next we have reaction due to ethereal oxygen. Now, like most of the reactions that we have done now, you must have seen it somewhere. But now we are going to do those reactions which are very rarely you have seen it anywhere, right? Not rarely, but they are very rare, like in NCERT it is not mentioned. So those who have not gone beyond NCERT, they are seeing this reactions for the first time maybe, right? Ethers add up atmospheric oxygen to form peroxides in presence of sunlight. So here, when you have excess of O2, either oxygen will be added here, right? One product will be that, and second product will be where this one hydrogen here will be converted to OOH. So two kind of peroxides are possible. Let me give you another example of that. For example, this is the ether. Either you can have one oxygen here that will give you this kind of product, that is one oxygen is converted to a peroxide bond OO, or you can have this hydrogen is converted to OOH, right? So this hydrogen here will be converted to OH. So these two things are possible here that leads you to the formation of peroxides from ether. Okay? Yes, everybody? Here this happens when you have excess of O2. In weeks and months this will happen, right? Okay? Then let's talk about electrophilic substitution reaction of ethers, that is same as we have discussed in aromatic. All you have to remember is ether is, if you talk about OR group here, right, in these cases, we know that here it shows plus M effect, right? Because directly to the benzene ring, you have the attachment of a group that has lone pairs. So it is going to show you plus M effect. That is why it is going to be ortho-para substituting towards electrophilic substitution reaction, because ortho and para you have negative charge here. So it is going to be ortho-para substituting, isn't it? That is the reason here when you see halogenation, right? Then what is the catalyst, what is the reagents that you use? Br2 in ethanolic acid is going to give you Br positive as an electrophile that will be attached on ortho and para position. Para position being the major because it is symmetrical in nature, right? Then in case of nitration, you have nitrating mixture, H2SO4H. This I have done like so many times, right? H2SO4 and HNO3. Again, NO2 positive is going to be the electrophile that will give you ortho and para product. No hydrogen bonding is there, so para will be the major product. Symmetrical is the major product, right? Then Friedel-Crafts, alkylation or acylation. In case of alkylation, you have the attachment of R positive at ortho and para position. In case of acylation, you have R C double bond O positive at the ortho or the para position. So COR at the ortho and para position, para being the major product here as well. Right, everybody? Understood? Yes, students, understood or not? Let's see. Let's see more things. Epoxides, then we are going to do distinguished test of alcohol phenols, right? We are going to talk about that. Let's see. Right, everyone? Let's see, here you have epoxides. Epoxides are three-membered cyclic ethers. Three-membered, firstly they are cyclic ether means, so here you will have oxygen. These are called epoxides, right? So based on epoxides also they ask you question that students usually skip. That is a part of ether only, right? So how firstly they are formed? By peroxy acid epoxidation of alkene. So what we do? Peroxy acid is the one which has, acid is C double bond O OH. Peroxy acid will be C double bond O OH. That is your peroxy acid. It will always have this kind of linkage here. That is your peroxy acid, right? So now if you talk about a peroxy acid, that is C double bond O OOH, right? In this case, whether you use CPBA or CF3COOH, that is the same thing. Alkene here, it will break and this will give rise to this kind of bond. Simple, break the double bond, this will break and this will give you rise to this kind of bond. That's it. That's the formation of epoxide from the peroxy linkage bonds, right? Okay. Second is base catalyzed cyclization of beta haloalcohol. Beta haloalcohol means on the beta position you will have halogen, right? So this position where OH is there, that is alpha position. Beta position is next to that carbon, that is beta carbon which has halogen. That is why it is called beta haloalcohol. On the beta position you have alcohol, and what you are doing? Base catalyzed cyclization. So base is there. We know that what is the work of a base? Base wants to abstract the proton, right? So base will abstract this proton which is quite acidic because of alcohol. So this will leave and here this will be bonded to this thing, right? So this will be negative here, this will be partially positive here, this is see, if you don't use here halogen, here, then this will not become partially positive. That's why we are using halogen, so that there is electronegativity difference and this become partially positive. Now this is negative, this is partially positive, so this negative, O negative will get attached here, and this will give rise to a cyclic ether, that is epoxide here. Okay, understood? Base will abstract the proton, O negative and C. This is not positive, this is partially positive because of the electronegativity difference. Right, everyone? So next is reactions of epoxides or cyclic ethers. What are the reactions of epoxides or the cyclic ethers? Let's talk about that. Ready, everyone? Till here, do you have any problem? Let's talk about cyclic ethers and their yes guys, please focus here, okay? Don't do unnecessary comments, be active, right? Okay, let's see this. Ring opening reactions of cyclic ethers. First is base catalyzed ring opening, right? That follows SN2 mechanism and nucleophilic attacks on less hindered carbon. So here Nucleophile will attack on less hindered carbon. Now out of these two, this is less hindered. This will go here and this will give rise to O negative. This is the nucleophile and hence H positive will be attached here after that. Right, so nucleophile, this is main important thing, that in presence of base, it follows SN2 mechanism, it follows nucleophilic attack on less hindered position. But in case of acidic, things will be opposite. So let's see this here. Example is, base is this one. This base has only one work. This base is going to attack on the less hindered side. So here it will attack, right? This will give rise to O oxygen 18 isotope. 18 means this is the 18 isotope. This is 16 isotope. This will be O18H. Now what will happen? One hydrogen will be added here. So this is O16 and this is O18. These are the isotope number. That means the one oxygen that you are adding is actually here, not here. Students, usually if I don't write here, when I don't write here whether this or this, students can get confused that ma'am whether you have added OH here or here. Right, if I add OH, whether ma'am you have added OH here or here. OH nucleophile or whatever you have, that is always added on the less hindered side. Okay. In case of acid catalyzed, things are totally opposite. In case of acid, it is SN1 mechanism, right? And nucleophile attacks on more substituted carbon, because more substituted is more stable. More substituted carbocation is more stable. So here, when this is acid catalyzed, in case of acid catalyzed, what will happen here? This proton is going to attack on this lone pairs and it will have a positive here. And now what will happen? This will, this nucleophile is going to attack on more hindered carbon. This one is more hindered now. So what will happen? Firstly, this bond will break here. So basically this will happen and this bond will break. And nucleophile will attack on the more hindered carbon. More hindered carbon. And the answer is nucleophile attacked here. So now that depends upon whether you have acid catalyzed or you have base catalyzed. Remember, in acid catalyzed, more hindered, in base catalyzed, less hindered. So you can say BL, or you can remember acid is high. AH or BL, I say just remember BP low. Base is less hindered. BP low. Base is less hindered. Okay. Example is this one. Here we can see that this is H positive. That means this is acid catalyzed. So what will happen? O18H will attack here and this will form OH here. So this will be the answer that you will have. Because here the nucleophile that you will have is O18H. But that will attack on more hindered carbon, that is this carbon. Okay, because it follows SN1 mechanism. Right, everybody? Let's see this question here, that is, you have an epoxide. Here, if you see, this is base catalyzed. Okay, this is base catalyzed. And if you see, nucleophile is this one. Nucleophile, this will be positive, this is negative. So, CH3 negative is the nucleophile here, right? Okay. So, base means nucleophile get attacked to less hindered side, that means here. And here you will have OH, so it will give rise to CH3, OH. This is CH2, CH3. Then we know that copper at 300 degrees Celsius, if you have 3 degree alcohol, that will give rise to alkene. For 3 degree alcohol, this is 3 degree alcohol, this will give rise to alkene, and alkene will be, this is not the correct answer, not the correct answer. So answer will be B is the correct answer. According to Sedgwick rule, alkene, more hyperconjugating structure alkene will be formed here. So B is the correct answer here. Yes, everybody? Okay. Is that clear? Let's see the last part of today's lecture, right? As I told you, the lecture is going to be sweet, small lecture because very less part was left, right? There are Diwali days, right? And I also got busy, and then we started off with our new series. That's why, there was no day free for me. That's why I thought of let's take this now before starting something new that is going to come up, right? Okay. Yes, everybody, let's see this. Now guys, let's see what you have. Test of alcohols, right? Test of alcohols. So based on test also directly the questions are asked. Let's see how the questions are asked here. So first is sodium test. Sodium test is take some organic compound in a test tube, add a thin slice of sodium, a brisk effervescence that must be of hydrogen. If that is produced due to evolution of hydrogen takes place, that means you have the formation, you have alcohol. Alcohol is there in that organic compound. So if you have with sodium, you will have brisk effervescence, and now ma'am, brisk effervescence can be of some other gas as well. So you can see pop out test of hydrogen as well, right? Okay, because it is like flammable, right? Then ester test. Ester test is if alcohol with acid, it forms very good aroma, right? So when warm the given liquid in acetic acid in presence of sulfuric acid, if you have a fragrant fruity smell, that is of ether, that means you have the formation of ester here. If a very beautiful aroma is there, then you have the formation of ester here, right? Okay, everybody. Alcohols give crystalline esters with 3,5-dinitrobenzoyl, right? This is one of the examples that alcohol with this one, they give crystalline esters. These esters have sharp melting point and can be used for testing a given alcohol. If you react this with 3, 5, 3rd and 5th position dinitrobenzoyl, then they give crystalline esters that have very good melting point. They can also be used for identification. Now this is a very famous test, that is Lucas reagent, that is concentrated HCl and anhydrous ZnCl2, right? So when you have concentrated HCl and anhydrous ZnCl2, right, you have how you distinguish it, right? So first is 1 degree alcohol, right, that reacts very slowly with this one, right? So it will give you, does not give appreciable reaction, very slow reaction is there, gives turbidity in 30 minutes, and that too after prolonged heating, it will give you the test, right? Turbidity means cloudiness. You have water, you put powder in that, the cloudiness that appears, same kind of cloudiness, right? Then 2 degree alcohols, they will give you this test, but after 5 minutes, right? And 3 degree alcohols will give you the test immediately. That means they are 3 degree alcohol. So from here you can not only tell whether they are alcohol, but you can also tell that they are 3 degree alcohols or 2 degree or 1 degree. And phenols do not give Lucas test. If you have to distinguish between phenol and alcohol, you can use this test as well, right? Next is Victor-Meyer test. This is not mentioned in your NCERT, but this is an important test, right? So you must go through this in detail. In detail it is not mentioned, so that's why we'll do this here. The given alcohol is converted into iodine by concentrated HI or red phosphorus and iodine, right? The iodine is treated with silver nitrate to form nitroalkane. Nitroalkane is finally treated with nitric acid and made alkaline with base. Now these are the things. Let's see what exactly he's saying. He is saying that firstly red phosphorus and I2 you will use, then AgNO2 you will use, then you will use HNO2, right? With primary alcohols they will make halide, both will make halide, okay? Then with AgNO3, I will be replaced by NO2. This I here will be replaced by NO2. Till the reactions are same, we don't have any. See, distinguish means we need to see the change in color or some smell, something should be there. Till now, nothing is there. Then we react this with HNO2, this also with HNO2. This with HNO2 will give you this H2 will leave from this side, right? That will, this oxygen will be there. This will give you C double bond O NO, right? And NO2 will be attached here. Same here, this here, NO2 will be attached here. Sorry, NO will be attached here. NO will be attached here. And here you will have NO2, right? Same thing is there. Here it is going to give you NO2 is going to attach here. And this will be double bond NOH. Here NO2 is already there. This attachment will be of NO, right? But ma'am, this also does not have a specific color. So ma'am, what is exactly there, right? When you, after this, when you react this with B's, if you have 1 degree, then it will give you blood red color, and this is the question that they ask you. Primary alcohols with red phosphorus, then AgNO2, then HNO2. After this, when you react this with base, they give red blood color, but 2 degree will give you blue color, right? And 3 degree, after this, they will show no reaction, so no color. So how do you remember this? Remember this by R, B, RBCs, we all have RBC, right? RBC, red blood cell, red, blue, colorless. Okay, 1 degree, 2 degree, 3 degree. Okay, this question can be directly asked to. Right, everybody? Okay. Then there is oxidation test, right? Oxidation you will do here. Take some organic compound in a test tube, add it to a strong oxidizing agent, that is K2Cr2O7 or concentrated and H2SO4. Heat the test tube after fitting the the solution becomes green colored. Test the aqueous solution of distill for carboxylic acid group. A positive test indicates the presence of primary alcoholic group. That means they are saying that when you pass it through, heat the test tube, firstly add acid, then you heat the test tube, right? Then the distillate will be passed into another test tube containing water, you will dilute it. The solution becomes green. Now, after the solution becomes green, that means this is the test for, then you test it for the carboxylic acid group, right? This means that if this is converted to carboxylic acid group, that means you had here primary alcohol, right? Okay. If you have the presence of ketone, that means there was 2 degree alcohol, right? If you had primary alcohol, that would have formed COH. If there was 2 degree alcohol, that would have formed ketone. This is what we want to say. For 1 degree, you will test carboxylic acid, like carboxylic acid test you will do. For if carboxylic acid test is positive, that means primary group was there. If carboxylic acid test is negative, that means secondary alcoholic group was there, right? Okay. Then there is steric ammonium nitrate test. So you add steric ammonium nitrate. If you have the formation of red color, then you can say that here you have the formation of alcohol, you had the presence of alcohol, right? A red color is produced. This test is useful only when compound contains less than 10 carbons per molecule, and it is also given by phenol. So you can't distinguish alcohol and phenol here. If this test is positive, that means either the number of carbons are less than 10 alcohol or it can be a phenol, right? So you can't distinguish alcohol and phenol from here, right? Then guys, we have aniline dye test. For that, first you will see this is the to form the diazonium salt. This is the mixture, that is NaNO2 and HCl, that we have HNO2, right? Firstly, aniline is converted to diazonium chloride by reacting with this mixture, that is NaNO2 HCl or HNO2 in 0 to 5 degrees Celsius, right? Now once you have disonium chloride, when you react this with phenol, para position, what will happen, this Cl and here H will be eliminated and you will have the attachment and they will show coupling reaction, N double bond, then you will have benzene, then OH. That is a orange color PPT. If in the, as this is called azo dye test, if in the coupling reaction, in the dye test with phenol, you have orange color dye, that means here you had phenol, right? Okay, because in case of aniline it is a yellow color, in case of beta naphthol it is scarlet red color dye is there, that we have discussed, right? Okay, and we will further discuss this in amines as well, right? Then guys, we have Lieberman's test. In Lieberman's test, take a small amount of compound and fuse with few crystals of NaNO2, right, in a test tube. Small amount of compound you do, fuse it with NaNO2, right? This is another test. Cool the test tube and add some concentrated H2SO4, right? A deep green color is obtained when poured into large excess of water. Green color changes to red, and when little NaOH solution is added, solution becomes deep blue color. So firstly, what we are saying, firstly you have the appearance of green color, then that changes to red color, then that red color changes to blue color. You take the test tube, you put the organic compound in that, react it with NaNO2, react it with H2SO4, deep green color will appear here. After this, when you dilute it, it will become red, and then when you add NaOH, here when you are adding water, it is becoming red. When you are adding NaOH, it is becoming blue. Okay? It means if all these variations are there, that means this alcohol is present here, right? Sorry, phenol is present here. So this is phenol. When you react with NaNO2 plus H2SO4, you have the formation of this. This NO group is attached here, right? Then it is tautomerized. Let's say this is 1, 2, 3. This will be 1, 2, 3. So double bond you will have here. So what will happen in this case, right? Full tautomerism will take place. This bond will shift here. This bond will shift here, right? This bond will further shift here. This hydrogen is going to shift here. This is the tautomerization that will be shown here. So you'll have OH, single bond, N double bond. This is single bond, double bond, single bond. This will be double bond O. That will be there, right? Now this is green color, right? Now you are adding, you are diluting this mixture further, right? That is converted to red color indophenol, right? Okay. Then you are adding NaOH into that, that is getting converted to blue color indophenol salt, right? If you don't want to remember any of this, please remember the color changes here, right? The colors that are being changed here, right? Okay. Understood everybody? Firstly, tautomerized green product is formed, then it is further poured into the same mixture, then red color compound is formed, then further blue color compound is formed when you add base into it. Right everyone? That shows the presence of phenol. Another reaction showing the presence of phenol is bromine water test. With bromine, when you react phenol, you have white precipitates or 2,4,6 tribromo, yellowish white precipitates of this compound is obtained. That means this is phenol is present here, right? Then you have FeCl3 test. This is also another test of phenol. When you have phenol reacts with FeCl3, then it forms colored complex with phenol or enol attached with sp2 carbon, right? It does not give test with alcohol. Alcohol will not give you this test. Enol will give you this test, or phenol will give you this test. Okay? Enol or phenol will give you this test. Okay, everybody? That means OH group. OH group, if it is attached to a carbon, that is sp2 hybridized, then this test will be positive here. Okay, right everyone? Last one is NaHCO3 test. Now we know that if you talk about NaHCO3, right, it's a salt which gives you, this is, we know that when you dissociate this is a weak base, right? And if you have a weak acid like phenol here, they are going to give you a strong base and strong acid by exchanging hydrogen here. So when you give hydrogen to this side, that becomes H2CO3, which is in mineral acids, this is a weak acid. But if you talk about in organic acids, this is a strong acid and this is a strong base. Why it's a strong base? Because it has very good resonating structure, so it's a strong base, right? Okay, and that is the reason when this phenol does not respond to NaHCO3. So we are saying that phenol will not respond to NaHCO3, right, but others will respond here, right everybody? Is that clear? Right? Now since H2CO3 is strong acid and this is strong base, equilibrium will be driven in backward direction, which means no effervescence of CO2 will be obtained. If you remember, I told you this in case of acidity and basicity as well, that reaction always proceeds towards weak acid and weak base. It always wants to go towards weak acid and weak base, not strong, right? So this reaction will occur backwards. That is the reason this NaHCO3 phenol will not react here. However, substituted phenol, if you have ortho-para substituted phenol here with strong electron withdrawing group, that makes phenol very acidic, then this reaction can take place. Thus, all the acids stronger than H2CO3 gives positive NaHCO3 test. Phenol is a weaker acid, all the acids that are stronger than H2CO3, they will give this positive test, like HCl, H2SO4, they will give positive test for this one. Picric acid, that will give positive test for this one, but not weak acids as compared to this carbonic acid. Okay? Let's see a question here, JEE Mains 2024, that is in the Victor Mayer test. The color given by 1, 2, 3, such a simple question, R, B, C, just remember, red, blue and colorless. So answer is going to be A is the correct answer here. Tell me guys, is that clear to all of you or not? Is that clear everyone? Done. So we have completed alcohol, phenols and ethers finally. Right now guys, if you see, we are left with aldehyde, ketones, carboxylic acid. We are left with amines, bimolecules, thermodynamics and equilibrium. These chapters I have never even touched here on this channel. So that's why I am going to take, right, really good sessions. But I want all of you to support me in that, right? If you are ready for that, do let me know in the comment section. And there is one more chapter, that is P block, that we will do in the end. Firstly, my target is these 5 chapters, then the last one, right? Okay, rest of the syllabus is already done. We are also doing revision side by side, and for a very good revision guys, we have our Sigma batch, right? And ma'am, what is that Sigma batch, ma'am? What is Sigma crash course, ma'am? See, in Sigma crash course, we are going to teach you high weightage topics, right? So really important, short topics. It's not like we'll teach you like some unnecessary topics, right? So what exactly happens in crash courses, the biggest drawback of crash courses is that everyone tries to teach everything, right? But the reality is that everything they are not going to ask. They ask you, there is some specific pattern in which they ask the questions, right? So what students do, 90 to 95% of the paper is predictable topics, right? So what students do, to save that 5%, they tend to ignore that 95, and sometimes 99.9 paper is from like predictable topics, right? So this is what I am telling you. Students try to save those 1 to 3%, right? And they end up not having marks from the high weightage topic that they knew will definitely come, and they do mistakes in that, right? So guys, firstly you need to do mastery on these high weightage topics, and for that we have Sigma crash course, where each topic we are going to teach you in detail along with the questions, right? Everything will do. But for that you need to register yourself, because that will not happen on YouTube. That will take place on our platform, on Vedantu's platform, right? And there is very minimal fees that we are charging for that. You can go and check that out. Very minimal fees it is, right? On the live section there is Shreyas sir's class that he has taken on Sigma crash course. You can go and check out all the details, because we are also providing you test series. We'll also take some test here related to those topics. Everything will be there in the batch, right? So all you need to do is check that out. And guys, always remember, right, that wait a minute. And guys, always remember that if you hold these topics, right, you have mastery over these topics, right, you will definitely like crack JEE with very good percentile. You will secure a very good seat, right? But for that you need to practice the question. You need to do from where should I, and how much amount of detail I should go for that topic. What are the different types of questions from one topic? 7-8 type of questions are asked. Sometimes they ask this kind of question, this kind of question. So every version we will teach you in this particular batch. Yes, your favorite Shreyas sir, Diksha Ma'am, Namrata Ma'am, Pahul sir, all of us are there in the batch, right? So we will be teaching you, and guys, we'll see you all in the batch, right? Are you excited for that or not? Yes? Chalo. Okay then guys, then bye bye, take care, and I'll see you all in the next class. The link for this batch is in the description. Go and get enrolled. 10th November this batch is starting, so don't miss that out. One single day is going to cost you a lot, so don't miss that, right? So see you all in the batch. Bye bye, take care.